Hello again, it's Professor Elliott. This is my JFET lesson number 3, and today we will look at the self-biased JFET, which is one of the common biasing methods. Okay, so here's the general arrangement. N-channel JFET, we know this because the gate arrow is pointing inwards. We have a resistor in the drain, we have a resistor in the source, and we have a gate resistor RG from the gate to the ground. And we'll see that resistor is essential for proper operation. Okay, so RD is the drain resistor, RS is the source resistor, and the gate resistor is RG. Okay, so those are all the currents and voltages identified. Please make note of them as we go forward. On the next slide I have calculations, so it'd be very helpful to you if you'd record this down before going forward. Thank you. Okay, so this here should be the gate resistor, and this should be VDD. So that would mean then back on here, that's 12. This is 10. This is 1. And that's 500 ohms. And we assume the drain current here is 3. That's my wife letting the hooligan dogs down here. They're really quite sweet. Okay. Calculate the voltage across the drain resistor. That's 3 volts. Calculate the drain voltage. This is 12. This was 3. That's the drain voltage from the drain down, all the way down to the common ground. Okay. The source resistor voltage. Okay, these are just partial diagrams, which you've obviously figured out. Equals 1.5 volts. Okay, the drain to source voltage. Between the drain and the source. Okay. But the gate voltage, do I have a diagram there? No, I don't. Okay, so the gate to source voltage is equal to 0. So that is the voltage from the gate to the ground. Do I? Yeah, I do have a diagram. So if that means then if this voltage here was 1.5, calculated it, right? And because this is a high value resistor, so essentially this is the gate going to the ground through a resistor. So this current here is the gate current. Okay. It's not zero, but it's approximately zero. So that means then essentially then there's no voltage across this 10 megohm gate resistor because the current is so small. So if this is the ground, that means this point is virtually or essentially at the same potential as zero. So if that is zero and this is 1.5, to make both those things true, that forces VGS to be at minus 1.5. So with the self bias, by adding the gate resistor, the source voltage is automatically made to be negative. So these two voltages are the same magnitude but opposite in polarity. Okay, so we'll go on to, I think it's JFET lesson number 4. Thank you very much. Bye.